Myself, Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, I want to discuss some problems based on formation of partial differential equation. How we can form a partial differential equation if a relation is given in our question. In our question, there may be constants. If constants are given in our question, then after eliminating constant, we can form that equation in partial differential equation. Otherwise, in a relation is given as a function, then eliminating the function from given relation, from given equation, then we can find a partial differential equation. So today in this lecture, I am going to discuss a problem. In this problem, we have given a function. So how we can convert this function in a partial differential equation? So we have already solved some problem on this topic in last lecture. So here, partial differential equation topic is some problem based on formation of PDE. PDE means partial differential equation. So here today I want to solve this problem 1. Problem 1 based on formation of partial differential equation. In short form, we can say PDE. PDE means partial differential equation. Form the partial differential equation from given function. Here we have given a function in the form of equation. There are two sides, left hand side and right hand side in this relation. Every relation have two sides, left hand side and right hand side. That is known as equation. So this function have three variables, x, y, z. X and y are independent variable, but z is dependent variable here. Z is dependent on x and y. So here we can differentiate z with respect to x partially by keeping as a constant, and we differentiate with z with respect to y keeping x as a constant. This is partially differentiation because z is dependent on two variables x and y. So here z always is a function of x comma y. Z is the function of x comma y. So how we can change this function in partial differential equation? How we can formation here a partial differential equation? So this is function given here. So after eliminating this function f, then we get a partial differential equation. So solution here, we start the solution of this question. This is very most important question. Okay, and very interesting question. Given us that here in our question, there is given a function or relation. Function in bracket x plus y plus z and comma x square plus y square plus z square, bracket close, this equal to 0. Okay. Function, suppose here x comma y. Function is this type, x comma y. In place of x, we given here x plus y plus z. And other variable y is given x square plus y square plus z square. So this is equal to 0, that is equation 1. We have considered this equation 1. Now, let x plus y plus z, this is u, x plus y plus z considering equal to u, this is equation 2. And x square plus y square plus z square equal to b, this is equation 3. So after putting this value in equation 1, here we have z. Z is the function of x and y. This is equation 4. We have differentiation of z with respect to x. That is known as a dou f over dou x. This is represented by p. And dou z over dou y, differentiation of z with respect to y, x keeping as a constant, means dou f over dou y. This is known as a q. This is equation 5. From equation 4 is the z is the function of x and y. From equation of 4, we know Euler formula. If any function dependent on more than one variable, suppose here z equal to function of x and y, and we want to total differentiate of z, that is known as a dz. dz is total differential of z with respect to x and with respect to y. So that is represented by d of function of xy. Then we can write this dou z over dou x into dx and plus dou z over dou y into dy. This is equation 6. Now, here dz equal to dou z over dou x is p dx and dou z over dou y is q dy. So this is very famous equation. If z is dependent on two variables x and y, this is equal to z, then total differential of z, dz equal to p dx plus q dy. This is Euler equation. This is known as a Euler's formula. dz equal to dou z over dx into dou z over dou x into dx plus dou z over dy into dou z over dou y into dy. This is known as a Euler's formula. This is proved by Euler's. Euler's is a very great mathematician, very famous mathematician. So this is known as a Euler's formula, Euler's equation. And in short form, we can write dz equal to p dx plus q dy. This is a very famous formula. We have used this formula to solve a partial differential equation. Okay. We also use this formula in Charpit equation to solve in Charpit method. To apply the Charpit method, then we use this formula, okay, to find the solution. So now here, putting the value of u and v, considering in equation 2 and equation 3, u is x plus y plus z and v is x square plus y square plus z square. These both value u and v putting in equation 1. Then we get f u v equal to 0. Okay. Here f x plus y plus z, comma, x square plus y square plus z square, this equal to 0. This equation 1. We consider here u is x plus y plus z. This equation 2. And v is x square plus y square plus z square. This equation 3. This 2 and 3 putting in 1. From u and v, from equation 2 and equation 3 in 1, then we get f u v. Then we get here f u comma v. This equal to 0. This equation 7. So putting this f u v equal to 0, this equation 7. Now differentiating equation 7 with respect to x, then we get y-Euler method. We apply find the derivative, same. We have discussed here function of x, y. Function f is the function of x and y. Then total differential of f, df. So we apply Euler's formula. Dou f over dou x into dx plus dou f over dou y into dy. This is Euler's formula. So similarly, we can write the formula of here f u v. In place of x is u and y is v. So f u v. There are two variables in this function. This equal to 0. So we can write here d over dx of f u v. Differentiation with respect to x. F u v. So we can write this formula. Dou f over dou u over dou x plus dou f over dou v over dou x. This equal to 0. This equation 8. This is very famous formula. Here two variables are in our function u and v. We want to differentiate of with respect to x. So first this function differentiate with respect to u and differentiation of u with respect to x partially. How we can here differentiate partially? Because in function there are more than one variable. U and v, two variables are there. So we differentiate the function first with respect to u. Dou f over dou u. And u is the function of x and y. So again differentiating of u with respect to x. So dou u over dou x. Plus again in function there is another variable is v. So again partial differentiation of function f with respect to v. So dou f over dou v. And v is the function of x and y. So differentiation of v with respect to x. Dou v over dou x. Okay. So basically in each term dou u cancel, then we get same this dou f over dou x and dou f over dou y. So here we apply here partial derivative dou f over dou x partially. Again differentiating equation 7 with respect to y. Then we get again y-Euler method. Next equation. Next equation is dou over dou y partially. Dou over dou y. So dou over dou y of f u v, again apply this Euler's method. So dou f over dou u, first of all differentiating function f with respect to u partially, because there are two variables in a function u and v. So v is constant, differentiating f with respect to u, and u is the function of x and y. So here we want to differentiate with respect to y. So differentiation of u here with respect to y. Dou u over dou y plus dou f over dou v. Next, second term function have second variable is v. So again differentiating f with respect to v. In partially u is constant in this term. So dou f over dou v, and v is the function of x and y. We want to differentiate with respect to y. So here dou v over dou y. This equal to 0. This equation 9. Here function given u comma v equal to 0. This equation 7. Okay. So here we want to differentiate with respect to x. Differentiating with respect to x. But u is the function of x and y. Here u is the function of x and y. And v is also function of x and y. Okay. So we want to differentiate with respect to x. Dou f over dou x. This equal to, we write here dou f over dou u and dou u over dou x plus dou f over dou v and dou v over dou x. This formula we can apply here. Next, dou f over dou y differentiating with respect to y, differentiating with respect to y, then we get dou f over dou u and dou u over dou y and plus dou f over dou v and into dou v over dou y. Okay, so this is formula. This formula apply here. Now from equation 2 and 3 we have, what is in equation 2? 2 is here u is x plus y plus z, this equation 2. Now differentiating u into with respect to x and y respectively. First we differentiate u with respect to x by keeping constant. Z is not constant, z is a function of x and y. So we can differentiate z with respect to x and we can differentiate z with respect to y. So here dou u over dou x equal to differentiation of x is 1 plus y is constant here, keeping y as a constant. So by constant we differentiate with respect to x, so y as a constant. And differentiation of z, dou z over dou x with respect to x. So we get here dou u over dou x equal to 1 plus dou z over dou x. But dou z over dou x is p. We have already discussed this topic. So we can write 1 plus p. Now, similarly, we can write differentiate with respect to y. U with respect to y. So dou u over dou y equal to, now x keeping as a constant. We want to differentiate with respect to y. So here x keeping constant. Differential with respect to y. So y differentiation of y is 1 partially plus differentiation of z with respect to y. Z is a function of x and y. So z differentiate with respect to y, x keeping constant. So we get dou z over dou y. 1 plus dou z over dou y equal to 1 plus q. Dou z over dou y is q. This is equation 10. This equation, both equation are 10 here. Dou u over dou x is 1 plus p. Dou u over dou y is 1 plus q. Here, dou u over dou x, this is 1 plus p. And dou u over dou y, this is 1 plus q. Okay. Now here we have y equation 3. B equal to x square plus y square plus z square. This is equation 3. In starting we have considered this equation u. U is x plus y plus z and b is x square plus y square plus z square. So differentiating b in equation 3 with respect to x and y respectively. So now here differentiating b. B is the function of x and y. So differentiation of b with respect to x, dou b over dou x. Y as a constant. So here x square, differentiation of x square is 2x. Y is square 0 because y is constant. So differentiation of y square is 0. Differentiation of z square with respect to x, dou over dou x of z square. So z square is 2z and again differentiating z with respect to x, dou z over dou x. So we write here 2z dou z over dou x. 2 is common, x plus z. Dou z over dou z is, dou z over dou x is p. So 2 into x plus zp. Now dou b over dou x is equal to 2 into x plus zb. This equation 11. Again differentiating b with respect to y here. So dou b over dou y. Now x is a constant. When we differentiate with respect to y to b, then x keeping constant. So differentiating of x square is 0 and differential of y square 2y with respect to y. And differentiating of z square, z is a function of xy, so x is keeping constant. Differential with respect to y. So here we write here 2z dou z over dou y. But dou z over dou y is q. So 2 is common, we can write y plus zq. So we can write finally dou v over dou y equal to 2y plus zq. This is equation 12. Putting all necessary value in equation 8 and equation 9. Then we get equation 8 and equation 9. Now, what is equation 8? We have right here equation 8. This is equation 8. Dou over dou x of function of uv equal to dou f over dou u over dou x plus dou f over dou v over dou x equal to 0. This is equation 8. Now, putting value here. From equation 8, we have following equation with the help of equation this 8. So here dou u over dou x, we have find 1 plus q, 1 plus p. Dou u over dou x, 1 plus p. And dou v over dou x. Dou v over dou x is 2 into x plus zp. 2 into x plus zp. This is 2. 2 into x plus zp. This both value putting here. Then we find here. So, dou f over dou u equal to minus dou v over dou x upon dou u over dou x. This term taking this side and this upon this. We get relation this. So, putting the value of dou v over dou x is minus 2 x plus zp upon 1 plus p. This equation 13. Similarly, we can write this dou f over dou u upon dou f over dou v equal to minus 2 x plus zp upon 1 plus p. This equation 40. We have equation 9. Same. Similarly, we have equation 9. So 9 equation here, dou over dou y fuv equal to same equation this 9 we have discussed in last equation, dou f over dou u over dou y plus dou f over dou v over dou y equal to 0. This equation 9. So putting here dou u over dou y, this is 1 plus q, and dou v over dou y, this is twice of dou u over dou v over dou y, twice of y plus zq, twice of y plus zq. Okay, so this both value putting here. Then we get here dou f over dou u upon dou f over dou v equal to minus dou v over dou y upon dou u over dou x. This term taking to this side and this upon this. Okay, this upon this. So we write this here minus 2 y plus zq upon 1 plus q. This equation 15. But in equation 14 and 15, what happened? In equation 14 and 15, left hand side is equal. In equation 14 and 15, left hand side is equal. Okay, in both equation, left hand side this result in 15 and this result in 14, both result are same. So here, now keeping equation 14 and equation 16 equal, then we have here this dou f over dou u upon dou f over dou v equal to minus 2 y plus zq upon 1 plus q. This is equation 16. Equation 16 and equation 14. Left hand side is same. So one side is same of two equations. Then we can put other side as equal. So now from putting here, now keeping equation 14 and equation 16 is equal, then we get. This is the second side of equation 14 and this is the second side of equation 16, because left hand side of both equation are same. Like this formula, x equal to y and x equal to z. This formula we apply here. So this side is same. So this side is eliminate. We can write third formula, y equal to z. Okay. This value x equal to z putting here. So we get z equal to y or y equal to z. So similarly we apply here formula. Now minus sign is cancel here. This equation 17. After cancel minus sign, we get x plus zp upon 1 plus p and y plus zq upon 1 plus q. This is equation 80. Here function eliminate. In this method, we have eliminated the given function which is given in our question. Okay. Then this question convert in partial differential equation. Eliminating method. Eliminating of the given function. So now here after cross multiply, we get here x plus zp 1 plus q. This side to this side. This is cross multiply. Using here cross multiply. Using cross multiply. Cross multiply. So x plus zp 1 plus q and y plus zq 1 plus p. Now multiply this bracket to this bracket. X plus xq, zp plus zpq. Now y plus yp, zq plus zpq. Okay. Now zpq cancel. Cancel pqz on both sides in equation 19. Then we get, after cancel out zpq on both sides, then we get equation this: x plus xq plus zp, y plus yp plus zq. This is equation 20. So xq here and here xq, this function xq, and here zq. Okay, similar terms taking one side. Similar term. This here is q, similar here is q common. So I am writing xq minus zq and zp, and here zp and yp, both common p, yp, and equal to y minus x. This x taking this side, y minus x. After factorizing, we get here. Here is p is common. In this term, p is common. After p common, z minus y. And in this term is q common. Plus q common means x minus z. And equal to y minus x. This is 21 equation. Okay. Taking minus common from each bracket on both sides. Then we get minus taking common. After taking minus common, bracket is just opposite. Like this. A minus v is common. A minus v. Taking minus common, then a is minus and v is plus. Minus, then b minus a. We can write this. In any bracket, if we take minus common, then bracket is just opposite. Positive term convert in negative and negative term convert in positive. So same here, z is positive convert in negative and y is negative, that is convert in positive. Similarly in this bracket, minus is cancel. Cancel minus sign on both sides, then we get here p y minus z plus q z minus x equal to x minus y. Okay. So this is required partial differential equation of given function. With the help of given function, we convert the function in this differential equation. This is partial differential equation. Okay. So this is very important question. How we can formatting a partial differential equation with the help of given any function. So this is the method second. Eliminating the function, we can change the function in partial differential equation. Now, I am going to discuss just now another topic that is also very interesting. Solution of partial differential equation by directly integration method. Any differential equation is given and we want to solve a differential equation, partial differential equation. Then we apply this method directly by integration. You can integrate directly some equations, some partial differential equations can be integrate directly. So here problem 1 is given here. Dou cube z over dou x square into dou y. We understand this question. Here is z. Z is a dependent variable and x and y are independent variables. Z is dependent on x and y variables. So B can differentiate Z with respect to x and y partially. So here first differentiate Z with respect to y one time, dou Z over dou y, and again differentiating two times Z with respect to x. So totally differentiation of Z with respect to x and y three times. So dou cube Z over dou x square into dou y means two time differential of Z with respect to x and one time differential of Z with respect to y. And this equal to function cos 2x plus 3. 2x plus 3y. This is wrong function. Cos 2x plus 3y. This function. Now start solution. How we can find solution of this partial differential equation of third order. This is third order differential coefficient with respect to y one time and with respect to x two time. Total differentiation three time. Total order is 3 of this partial differential equation. So if we want to solve this differential equation, so we integrate this differential equation 3 times because there is order is 3. Every integration cancel one order of the partial differential equation. If there are 3 order of the partial differential equation, then we integrate 3 times. Then order is 0. Then we get a function z. And z is a some function of x and y. So now integrating one with respect to x. Partially on both sides by as a constant. When we integrate with respect to, how we first integrating with respect to x, because outer variable is x. Here outer derivative, last derivative is x, first derivative is y, last derivative is x here. So we cancel the derivative is last derivative cancel first. So integrating equation 1 with respect to x by as a constant. So now here integration this dou cube z over dou x2 into dou y dx, integrating with respect to x on both sides. In right hand side, integration of cos 2x plus 3y dx. So here adding some arbitrary constant, but now be integrating equation 1 with respect to x, then at this time y is constant. So be adding some constant adding in the function of y, not constant c1, c2, not adding here, we adding here some function of y because y is constant. We are integrating here with respect to x, so y is constant. So now we are adding, after integrating, we adding here one arbitrary constant. So be taking some function of y because y is here constant. Fy is constant with respect to x. So here if we integrating this one time, then one order is cancel. We integrating with respect to x here. So one order of with respect to x, one order is cancelled. So we get here dou 2z over dou x dou y. Okay, this is the integration of this function. This function convert in two order. Here is three order, one order is cancelled. So order is x decrease of order x. This equal to integration of cos integration of cos is sine 2x plus 3. But we here integrating with respect to x. So the coefficient of x is 2. Coefficient always goes to in denominator. So 1 upon 2 sine 2x plus 3y. And 3y is constant. With respect to x, y is constant. So this term is constant. Plus here adding some function of y as a arbitrary constant. This equation 2. Again integrating equation 2 with respect to x on both sides, y as a constant, because here outer derivative is x. we cancel first x, last y. So we had two order of x with respect to x, second order with respect to x. So we cancel one order derivative here with respect to x. Now again we cancel one order derivative with respect to x here. So we integrate again with respect to x. So now integrate this equation to dou 2z over dou x dou y integration with respect to x equal to 1 upon 2 sin 2x plus 3y plus fy dx. Here again integrating fy also constant function, so integrating this constant with respect to x and adding another constant, this is arbitrary constant. Here we are integrating with respect to x, so y is constant, so another constant is gy. G is some function of y is constant here. So now next dou 2z over dou x dou y into dx integrating with respect to x equal to integration 1 upon 2 sin 2x plus 3y dx. We are breaking the integration in bracket. Here is bracket. We apply bracket. So there are two functions sin 2x plus 3y and fy. So integrating separate function. First function this and second function this. So I am writing integration separate function 1 upon 2 sin 2x plus 3y dx plus integration of fy dx. This is gy constant. So now here one order is cancelled with respect to x. Order of x is cancelled. So here we get this result dou z. This one order is cancelled. Dou 2z over dou x dou y dx equal to 1 upon 2 sin 2x plus 3y dx and fy is constant here. Fy is constant here. So this constant we are integrating with respect to x here. So fy is constant, this function is constant, this is taking out of the integral. So we write out of the integral fy. Here is one number, one is dx and plus gy. So integration of 1 dx, that is x. Okay, this is x. So I am writing fy into x plus gy. And integration of sine is minus cos. Integration of sine x is, this is minus cos x. So now here integration minus cos 2x plus 3y. And here x multiply by 2, so 1 upon 2 here. Okay, so here is 1 upon 2 minus 1 upon 2 cos 2x plus 3y. Here is cos 2x plus 3y and plus fy into x plus gy. This is equation 3. Now in our left hand side there is z differentiate with respect to y, only one order derivative there. So now we removing y. Here is differentiating with respect to y, so removing y. So we integrate with respect to y. Then this order is cancelled. So again integrating with respect to y, equation 3 on both sides, x as a constant, then we get here. So now in next, here integrating dou z over dou y with respect to y equal to, here minus 1 by 4 cos 2x plus 3y. Here is cos, here is cos 2x plus 3y. Here apply bracket minus 1 by 4 cos 2x plus 3y plus fyx and gy in dy plus phi x. Now here we are integrating with respect to y, so x as a constant. So again we are integrating third time. So third arbitrary constant should be adding here. So here phi x is constant, so phi x some function as a constant. So we are adding here phi x. Now here dou z over dou y with respect to integration y, here minus 1 by 4 is common. We are separating the terms. There are three terms, 1, 2, 3. So they are separating term here, minus 1 by 4 and cos 2x plus 3y, this, and plus x. Now X is constant, so I am taking X is out. Here Fy dy and plus Gy dy plus phi x. Here let f integration Fy dy is phi 1 y. This is unknown function Fy dy. Fy is unknown function, though we cannot integrate this function. So here consider some function, some integral of this function. So that is integral. Here consider this integration Fy dy equal to phi 1 y. Otherwise we can write same as here, not change in this result. So we consider integration of this function is phi 1 y and integration of this function is phi 2 y. So putting this value in this equation, we get here z equal to, here one order is cancelled, this dy, this cancel, only z is there. This equal to minus 1 by 4 and cos is sine. Integration of cos is sine 2x plus 3y. We are integrating with respect to y. So here coefficient of y is 3. So 3 goes in denominator. So minus 1 by 4, 1 by 3 sine 2x plus 3y plus x. Phi 1y plus phi 2y plus phi x. So this is required solution of problem 1. Now next problem 2. Here dou 2z over dou x dou y. This is second order partial differential equation. Differentiate with respect to y first and x second. X is order differentiation. First differentiate z with respect to y and after differentiate z with respect to x. So here 2 time differentiation of z with respect to y and x. So we integrate this question 2 times. First with respect to x integration, then x order is cancelled. Again we integrate this y, then we get the value of z. In right hand side function is x square y. So this is partial differential equation of second order with respect to y and x. So this is the order y and x. Integration is just opposite. Integration is x and y. First integrating x and second y. So now start solution. Dou 2z over dou x dou y equal to x square y. This is equation 1. Now integrating 1 with respect to x. Partially on both sides y as a constant. With respect to integration with respect to x, other variable as a constant. So dou 2z over dou x dou y dx with respect to x. So one order is cancelled. This one is cancelled. Integration cancel one differentiation. Integration just inverse of differentiation. Either in ordinary differential equation or partial. In same. One differentiation cancel by one integration. So here in this side function is x square y dx. We are integrating here with respect to x. So y is constant. So we are adding here one arbitrary constant. So we are adding some function of y. Fy is adding here. Fy is constant here. Here Fy is a constant. Is a constant. Arbitrary constant with respect to x. So integration of this dou 2z over dou x dou y dx equal to y. Y is constant here. So y taking out. Integration of x square dx plus Fy. Now one order is cancelled here. So we get only dou z over dou y equal to y. Integration of x square. Integration of x square dx, this equal to answer x cube by 3. Okay. So we write here x cube by 3. Y into x cube by 3. And plus Fy. This equation is 2. Again integrating equation 2 with respect to y, because here differentiation of z with respect to y. So order of the given function with respect to y. So we integrate this with respect to y. Then this order will be cancelled. So now integrating with respect to integrating equation 2 with respect to y on both sides, x as a constant. Then we get x as a constant. So now dou z over dou y integrating with respect to y. So dou y is cancelled. Here is dz. Integration of z is z. Now by x cube by 3 plus fy dy. There are two functions here. And phi x is constant. Integrating with respect to y. So x as a constant. So we are adding here some function of x as a arbitrary constant. This equation 3. Now breaking this function in two parts. X cube by 3 is constant with respect to y, taking out integration of y dy plus fy dy and phi x. This equation 3. Let here this function y is unknown function. So integration of fy dy considering some function. Integration of fy dy is phi 1y. This equation 4. This value putting in 3. Then from equation 4 putting in equation 3. Then we get z equal to x cube by 3 y square by 2. Y square by 2 means here integration of y dy. Integration of y dy means y square by 2. Okay. So putting this value here, we get y square by 2 and plus phi 1y. Phi 1y is a value of integration f1 fy dy. Okay, this is let. Consider this. So now finally x cube by square upon 6 plus phi 1y and plus phi x. This is z. This is solution. Required solution. This is required solution of problem 2. So in our question, if any partial differential is given here, so we can solve some partial equation, not all. This type of partial differential equation given in our question, then we can find the solution with the help of direct integrating the partial differential equation. Then we get solution. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.